Hello everyone and welcome back. My name is Mr. Koval and today we are going to start to talk about molecular formulas and how to find the molecular formula. So normally this is done in conjunction with a problem where it's asking you to find the empirical formula first. So you would find the empirical formula and then the last part it would ask you for the molecular formula as well. And finding the molecular formula is actually really easy. It's the easier part of the problem or the shortest part of the problem. So in this one, I'm going to go over two examples where you are given the empirical formula and you need to find the the molecular formula. Now, the one thing you need in order to find the molecular formula is you need to be given the molar mass or some way to calculate the molar mass of the actual substance itself. And so I want to remind you guys that the difference between the empirical formula and the molecular formula is that the empirical formula is the lowest whole number ratio. It's the simplest version of the formula. Now, the examples I like to use because they're clear is if you use water, for example, water versus hydrogen peroxide, right? These are the actual formulas of the two substances. So the actual molecular formula, so this is the molecular formula for hydrogen peroxide. So in the formula, or in one molecule of hydrogen peroxide, you have two hydrogens and two oxygens. In the one molecule of water, you have two hydrogens and one oxygen. These are the molecular formulas. But the empirical formula can either be the same as the molecular formula or it can be different. If the molecule already has the lowest whole number ratio, like we see in water, right? So you can't get any simpler than 1 to 2 as far as whole number ratio goes. So the molecular formula of water is the same as the empirical formula. The empirical formula for hydrogen peroxide, however, is different because you can see that there's a 2 to 2 ratio there, 2 to 2. That's not the simplest ratio, so you can simplify that a little more. So 2 to 2 is the same ratio as 1 to 1, and so HO would be the empirical formula for hydrogen peroxide. So the empirical formula can be the same as or it can be different, but one thing you want to keep in mind is that the difference is going to be some factor between these, right? So you'll see that in order to go from the empirical formula to the molecular formula, I need to multiply by 2, so by a factor of 2. If you know benzene is C6H6. That is the molecule of benzene. So the molecular formula of benzene is C6H6. It has 6 carbons and 6 hydrogens. But the empirical formula, if I simplify this to a 1 to 1 ratio, it would be CH. Right? So the difference between the empirical formula and the molecular formula for benzene is a factor of 6. So the difference between your empirical formula and the molecular formula will always be some factor. And when you're trying to find the molecular formula from the empirical formula, you're going to use the molar masses of the empirical formula that you just found or that you're given, and then compare that to the molecular formula of the actual substance. And you can do that by dividing, right? So if you have if they give you the molecular formula, the molar mass, the molar mass of the molecular substance, of the molecular formula, right? So I'll just put MF for molecular formula. And then you're going to divide that by the molar mass or formula mass of the empirical formula that you found or that you're given. And so that is going to give you some sort of ratio or some whole number, right? So if it's equal, then it's going to give you a number 1. And that tells you that the empirical formula and the molecular formula are the same. If you get a 2, if the factor is a 2, then that means you need to multiply your empirical formula by a factor of 2 to get the molecular formula. And if it's a 3, then you need to multiply by a 3, and so on. Okay? I hope that makes sense. So what I will do is I will do a couple of examples to clarify what this means. Alright, so the first problem, I have butane dione contains the elements carbon, hydrogen, and oxygen. So they give you the elements. The empirical formula. So they give you the empirical formula here. So in another problem later in another video, I will go over where you actually have to find the empirical formula and then the molecular formula. But these two problems, they give you the molecular formula or the empirical formula. So they give you the empirical formula and they give you the molar mass of the actual substance. So this is the molar mass of the molecular formula, right? So in order to figure out what factor we need to multiply by, we need to find the empirical formula for this, for our we need to find the formula mass for our empirical formula, and then divide that into the molar mass. So let's go ahead and calculate that out. So we have 2 carbons. So carbon is 12.011, right? So let me go ahead and write this out. So we have 2 carbons, so 2 times 12.011, right? That's going to be grams per mole, plus we have hydrogen, 3 hydrogens, 1.008, and that's going to be grams per mole. This is going to be grams per mole. And then we have oxygen. We only have 1 oxygen, so 1 times 16.00 grams per mole. And then we calculate that out. So if we calculate that out, it's going to be 2 times, oops, let me do this way. So 2 times 12.011 plus 3 times 1.008 plus 1 times 16.00 equals, and I get 43.046. So I get 43.046 grams per mole. Okay, so this is the formula mass for my empirical formula. This is the molar mass of the actual formula itself. So to get my factor, I take this 86. I take the molar mass of the molecular formula. So the molar mass, 86.09 grams per mole, and I divide that by what I calculated for my empirical formula. So that's going to be 43.046 grams per mole. And you can kind of see already that 86, 43, that looks like a 1 to 2. So it looks like that this is going to be a factor of 2. So if we do that, we divide 86.09 divided by that number equals, and I get sure enough, I get like 1.9999. Okay, so that's basically 2. So I have the factor of 2. So to get to get the molecular formula, I need to multiply the subscripts by 2, right? So if I multiply by 2, I get C4. 3 times 2 is 6, H6, and 1 times 2 is 2. So this becomes the molecular formula for butane dione. Okay, so that's the molecular formula. Okay, so I hope that was clear. We'll go over another problem. So again, here we have a compound Oh, and by the way, butadiene is the chemical that's responsible for the smell and taste of butter and cheese. So just to let you know. All right, so number 2, we have a compound that has an empirical formula of CH. So CH is the empirical formula, and its molar mass is 78.11 grams per mole. What is the molecular formula? So we're going to do the same thing again. We got to calculate the formula mass for CH, and then we need to find the ratio of that to the molar mass for the actual substance. So we're going to divide this into that. So, but we need to calculate this, so it's easy because it's 1 each. So we have 1 times 12.011 grams per mole plus, and then we have 1 hydrogen, 1 times 1.008 grams per mole. So we add those together. So we're going to add 12.0111 plus 1.008 equals, and we get 13.019. So we get 13.019 grams per mole for the empirical formula mass. We are given 78.11 for the formula for the molar mass of the actual substance. So we're going to divide this into that. So let's do that over here. So we have 78.11 grams per mole. We're going to divide that by this, so we get a ratio of the formula, empirical formula, to the molecular formula. So 13.019 grams per mole. And let's see, it looks like it's going to come out to be about 6, but let's just find out. So 78.11 divided by that number equals, and we get 5.99969. So we get equals 5.99969. So that's really close to 6. So we can round to 6. So that's pretty much 6. So the factor is 6. So that means I need to multiply my empirical formula by 6, but the subscripts by 6 to get the actual formula. And the answer is C6H6. So that's the empirical formula, or that's the molecular formula for this substance. And it looks like we have benzene, since that's the formula for benzene. Okay, so that's how you find the molecular formula. You have to be given the molar mass of the actual substance itself, and then you compare the formula mass for the empirical formula with the molar mass that's given, and that should give you some sort of factor, either a 1, a 2, a 6, a 4, or 5, whatever the case may be. All right, thank you for joining me. I hope this was helpful. In my next video, I will actually go over a problem where you start from the beginning. You have to find the empirical formula and then find the molecular formula. So if this was helpful, please like the video, share the video with others, make a comment in the comment section, tell me what you think, subscribe to the channel. So subscribe please, and ring the notification bell so you can get notified for future videos. Thanks for joining me, and I'll see you next time.